We'll be discussing problems from worksheet number 8. And I selected them from your previous tests, sort of as a revision for your exam, right? So let's look at the first question here. We are given the fact that the second derivative of f of x minus the first derivative of f of x minus 2f of x is equal to 0. And we're given that the first derivative of f of x at the point 0, at x equal to 0, is equal to minus 2, and f of 0 is also equal to 2. Now we're asked to find f of 1. So let's just copy this. Any ideas? Any suggestions from you guys? How should we tackle this? Because it's in like in an exam or sets or test setting, you would want to solve these type of questions very fast so you don't lose time on them. So what I would suggest is, if you have an equation like this, right? It's a differential equation. So because you're given already f of you're given f of f of 0 and f of sorry, can you mute yourself, please? Thank you. So you're given f prime of 0 and f of 0, right? So I think you should be able to substitute this into the equation, right? Right. So if you do substitute it into the equation, what do you find? Right. So let's attempt that. Let's say we substituted x of 0 into our equation there. Right. So then we would have, please mute yourselves. Right. And so this would be then equal to, since we're given all these values, f double prime of 0 would be equal to it would be equal to f prime of 0 is given as minus 2, so you have minus 2, right? So which is 2. 2 minus 2 times f of 0. F of 0 is 2, so you have 2 minus 4, which is minus 2. Then when it goes to the right-hand side, it becomes 2. So f double prime of 0 is 2, right? So intuitively, you can already sort of see that yeah, you can already sort of see that the function, you're given sort of values of the function at 3 different conditions. And if you were to say that, for example, what function would you substitute in 0 such that it gives you 2 is equal to, sorry, such that it gives you 2 when you substitute 0. Okay, so think of functions, for example, right? Any functions that you can think of. What functions would you be able to, right? So we can sort of imagine, right? We have 3 conditions. That function needs to be such that when you substitute 0, you get 2. When you substitute 0 into the derivative, the first derivative of that function, you get minus 2. when you substitute 0 into the second derivative of that function, you get 2 as well, right? So let's say, for example, that f of x, okay, f of x is equal to the function that you're trying to find is equal to, let's say, something like 2, 1 minus x, okay? Because you're trying to find a function that such when you substitute in 0, you get 2. So when you substitute 0 there, you get 2. When you derive this expression here, right, and you substitute 0, you also, please mute yourselves. Right, when you substitute in 0 into the derivative of this, right? So let's say that's the function, then the first derivative of that function, right, would be minus 2, right? Which also follows with the with the expression there, right? But now, if you substitute it for a second time, right, you would have 0. So our function here doesn't quite work out. So now you can clearly see that if you're trying to if you try to repeat this process multiple times, right, you would find yourself in a situation where you actually have to, sorry, just give me a minute. Just trying to see. So you would find yourself in a situation where you are keep like coming up with functions, but they don't work out, right? So you keep coming up with functions, but you still get that maybe it works for 2 of the function. Maybe it works for f of 0 and f prime of 0, but it doesn't work for the second derivative, right? So quickly then, you sort of have to use your imagination, right? So since this type of functions, polynomial function, doesn't work out, now you have to pay attention to the fact that what function would you have, right, such that when you take the original function and you substitute 0, but you also take the first derivative of that function, it gives you the same thing, right? So now I know it's a bit it's a bit hard to understand it, but that's what you basically have to do, okay? So I will give you guys a moment time to think about this, and then in tomorrow's session we'll come back to this problem, right? Because I found that this one was a very interesting problem that we could look at. Okay, so we'll definitely come back to it again tomorrow. The one that I found that was particularly challenging was the last one here, which is where you're given the derivative of f of x is equal to g of x, and you're given the derivative of g of x, which is equal to f squared of x, right? And now you asked to find the derivative of the second derivative of f of x cubed, right? So the way you would do this, right, is you would use your sort of what is it, chain rule for derivatives, right? So let's say you're looking for the derivative of some function, right? Some function f that is of the third order, right? Meaning it's in x cube, right? So what the chain rule tells you is you have to take the derivative of the outside function first, right? Which is df dx, right? The derivative of the outside function, and then you derive the inside function. So in terms of x as well. So whatever the polynomial is in the function f of x, such that it's of the third order, right? So it's a term in x cubed. Then when you derive that term, you should get, right? What's the derivative of x cubed? You should get something that looks like 3x squared, right? That's the derivative of x cubed. So that would be your chain rule. But now we've already established, right? What is the derivative, right? We've just established what's the derivative of f of x as a function of x cubed, right? So now let's say that we're trying to find the second derivative of this, right? Because that is what they're asking us to find, right? So meaning you take the derivative of the derivative. So now let's write that down. Let's say you're trying to find this derivative of the derivative of f of x cubed, meaning you're trying to find the derivative, right, of df dx 3 multiplied by 3x cubed, right? So now here, you use the product rule because you have the product of two functions, right? You have the product of the function df over dx and 3x cubed, right? The product rule tells you that you first take the derivative of the first function, you leave the second function, plus the derivative of the second function, leaving the first function as it was originally, right? So when you translate that, it means d squared df squared, which is just the second derivative. Oh, sorry, dx squared, which is just the second derivative of f, right? Of our function f, right? Multiplied by the original 3x squared. Maybe I should just take the f up here so it doesn't look like it's f of 3x squared, right? Plus you leave out the first function, so df dx comes back, multiplied by the derivative of the second function, which is 6x. Right? So at this point already, if you are in sort of like a if you're in a rush, but you got to this point, it would be very important to already see that you have 6x there, right? So you have 6x there, which is also in one of the options, right? But in none of the other options. So you can sort of already see where it should go, okay? That doesn't mean that you know the answer already, but if you're in a rush and you got to this point, you would be advised to just take the third option, right? But we want to get to the point because we are not in a rush, so we want to get to the final answer, right? So here, the first section here now, it's asking us for the derivative, second derivative of f, of our function f, right? But we were already given What were we given? We were given that we were given that our function, sorry, just give me a minute. I think there might be a notation issue there. Okay, right. So we were given that df dx, right? df over dx is just equal to g of x, right? So let's just copy that. And we're given that d of g of x, right? Which is just, so let me just write that down so it makes more sense. So in the first term here, we have the second derivative. So let's write it back as the first derivative, right? This was basically this, right? Multiplied by 3x squared, right? And then on the second side, df dx was given to us as g of x already, right? So let's write g of x there, multiplied by sorry, just a second to check the options from your test. Okay, yeah. So we're given that df over dx is just g of x, and this is multiplied by 6x, right? But now this is equal to what? Okay. Remember that df over dx is g of x, right? So here in the first part, we're basically looking for d over dx of g of x, which was given to us as f squared, right? So let's just write that fx squared, sorry, multiplied by 3x squared, right? Plus g of x multiplied by 6x, right? So now here is where you have to sort of use your thinking as well a little bit. So let's look at what's given to us here. So we're given originally that d over dx of f of x is equal to g of x. And we're also given that g of x is equal to some function f, but to the x squared, right? So now remember that when you have when you take the derivative of a function, especially a polynomial, or which is our, let's assume that that's our case here, it always goes, when you take the derivative of that function, it always goes 1 degree lower, okay? 1 degree lower than what it was. So if originally g of x was a function in x cubed, and then you took the derivative of it, then it would become a function in x squared. Okay, so now if g of x was a function in x cubed, then the derivative of then f of x would have to be some function in x squared, in x to the 4, right? I'm not sure if that makes sense. Are you guys following? Just give me a thumbs up or something. Okay, yeah, so I will repeat that again. So we are given that g of x, the derivative of g of x, gives you a function f that is of the second order, right? So it's in x squared, second order. But remember that when you take the derivative of a function, it goes it goes to a lower, 1 degree lower than it's the original function, right? That especially applies for like polynomials. So if we assume that all of these functions are polynomials, right? Then we have the fact that if the derivative of g of x is a function in the second degree, in this of the second order, then g of x itself is a function of the third order, right? And then um and then therefore, if g of x is of third order, f of x must be of the fourth order, since f of x is just since g of x is just the derivative of f of x. Okay. Right. So I hope that makes sense. Okay, so maybe I can rewrite it so it makes a little bit more sense. Okay. But okay, no. Yeah, let's right. So f of x is a function of the fourth order. But what happens when you substitute in that function f of x, right? X squared. Then you would get something to the sixth order, right? So, and that is what I want you guys to attempt, okay? So basically, you've gotten this far. We have gotten this far, right? So all you need to do is use these identities that are given here, right? These two, to change this, because you already know from your tests that the correct answer that you should get is C here, right? So what I want you to do is work backwards. So go from this to get that, okay? using these expressions that are given there. Okay, so that's what I want to attempt. Then let's do, okay, let's look at, I think the limits questions I'll keep them for tomorrow. And then let's look at 4, because 4 was also interesting. So we have a function that is given to us, right? Let me just make some space here. So we are given this function, y is equal to e to the nx, right? And the question that we asked is to find what does the nth derivative of f of x, right? Which, sorry, I think this meant y of x. Okay, so this would make more sense. The nth derivative of y, right? In terms of x, right? So let's first take this first derivative. So in this case, you sort of need to take a certain number of derivatives and then see what it looks like. Okay, so the first derivative of y in terms of x is, remember, you use the chain rule. So what's the derivative of e to the nx? The derivative of e to the nx first comes back as e to the nx, right? Because the derivative of any exponential function e, especially with base e, is just equal to that function. And then you take the derivative of what's in the exponent side. So the derivative of nx is just n, right? So let's put the n in front of e here, right? So that's the first derivative. So now let's look at the second derivative. And I will explain just now why we are doing it this way. So if we take the second derivative, then we have, as you can see, the n is a constant, right, in the first derivative. When you repeat the same process, there will be another n that comes, so that becomes n squared multiplied by e to the nx. Okay. So now repeating the process multiple times, what do you notice, right? So if you repeat this process for the third derivative, let's just do that for completion. If you take the third derivative of that, you really only need 3 derivatives to sort of understand the pattern and what's happening. If you take the third derivative here, you can see that another n will add up there. So you have n cubed times e to the nx. So you can already see a pattern, right? So whatever the derivative you are on, it will be just equal to n to that nth derivative, right? So whatever it is, it could be the third derivative, the second derivative, the fourth, the first, multiplied by the original function, right? And what that means is if you were to continue with these derivatives all the way to the nth derivative, right? The nth derivative would just give you n to the nth, right? Multiplied by the original function. Because remember, the exponential just comes back, right? So that is what your final answer should be. So it should be option A here in our case. Okay, so hopefully that makes sense. Right? So now let's look at 7 here, which is telling us that what happens if we have some function sine x is equal to e to the y, right? And we asked to find dy over dx. So now let's derive on both sides, right? Let's take the derivative on both sides. So when you derive sine of x in terms of x, you just get cos x on the right-hand side. And then on the left-hand side, you remember exponential. It will come back as is, and then multiplied by the derivative of the exponents, which is dy over dx, okay? So now, when you solve for dy over dx in this expression, you get cos x, right? Divided by e to the y, right? But they were asking you to find this solution in terms of x, not y. So you need to eliminate this y here. But you remember that what you're given is e to the y is equal to sine x. So this is just equal to cos of x divided by sine x, okay? Which is just equal to cot of x, right? So it should be option E here. Okay, nice. So for questions 5 here, let's look at question 5, which is also interesting. So for question 5, you are given the fact that f prime of x, which is the first derivative of x, is equal to minus f of x. And you're also given the fact that f of 1 is equal to 1. And then they're asking you to find what is the function f of x. So now here, you can move by elimination, okay? Since you are working fast, you can move by elimination. So let's say we consider the first option first. So the first sub answer, let's say we take f of x is equal to e to the 1 minus x, right? So let's take the first derivative of that. So what is the first derivative of f of x in that case? The first derivative of f of x then becomes the original function, right? It's an exponential function, 1 minus x, multiplied by the derivative of what's in the exponent sign, which is the derivative of 1 minus x, which just gives you minus 1, right? So immediately you can see that this function respects the fact that f of x is equal to just minus, minus f prime of x, right? Which is the first assertion that they tell you f of x should satisfy. So A satisfies that. Now, let's take f of 1. Is f of 1 equal to 1? Well, when you substitute the value of x into f of x, you will have that f of 1 therefore is equal to e to the 1 minus 1. So e to the 0, which is equal to 1. So the two expressions are satisfied. Therefore, the answer must be A. Okay. So you can sort of quickly do these sort of like elimination processes to find your answer. Another quick way you could do this is, let's just say you start substituting 1 into each of the options and see if you get 1. So let's say you take you chose the third option, for example. Let's say f of 1. What happens? It's minus e to the 1, which is minus e, which is not equal to 1. So the answer is definitely not C. If f of x is equal to e to the minus x, you substitute 1 into it. You have e to the minus 1, which is not equal to 1. Substitute 1 into e to the minus x minus 1 is equal to e to the minus 2, which is not equal to 1 either. So you've already eliminated option C, D, and E. Take it back to option 2 now. You substitute f of 1, you have e to the minus 2 plus 2, which is e to the 0, right? And e to the 0 is 1. But now multiplied by 1 over 2, the answer is 1 over 2, which is not what we said f of x should be, right? So you have already eliminated all 4 options, then the correct option must be the first one, okay? So that is how you should sort of deal with these types of questions. So now in tomorrow's session, we'll look at, we'll come back to question 1, question 2, 3. We've done 4. So we'll do question 6 as well, which was also interesting, as well as question 8, which we'll finish up, right? So yeah, that's it.